Hello guys, in this video we're going to talk about the absolute value inequalities. Um, I'm going to create two different video lectures. In the first one I'm going to go over the problem on the first page. I'm going to work with this example step by step, and then I'm going to ask you to try to work these problems on your own, the ones on the second page. So once you're done with that, uh, you are going to check a second video, which is a video about the solutions on the second page, to check your understanding. Okay, so for today we're going to focus on absolute value inequalities in which the sign is less than or equal to. And then tomorrow we're going to talk about absolute value inequalities with sign that is greater than or equal to. Now the first two problems are more like a warm-up problems. I'm not gonna go over them. The first one is just to solve a linear equation. The second one is a review of what we did the first 2 days, which is the absolute value equation. I remind you that once you have the absolute value by itself, you need to set up two equations. One, you're gonna have a 2b plus 9. It's gonna maintain the sign, and the second equation is gonna be with the negative 2b minus 9. You're gonna solve the two equations, plug it into the original, and make sure that the left hand side is equal to the right hand side. If it is not, then you're going to have some extraneous solutions. Okay? Alright, so let's start with something basic on absolute value inequalities. So here we have an absolute value of x which is less than 3. Now in order to understand how to graph the solution or to find the solution, we need to recall the meaning of absolute value. Absolute value, I remind you, represent the distance of a number from 0 on a number line. So if I say that the absolute value of x is less than 3, what this means is that the distance of a number from 0 on a number line is less than 3. So what this means is that the distance must be less than 3. Okay? So if I pick up, for example, 0, right, I'm at 0, well, 0, right, this point has a distance from 0, which is 0, right, so it's less than 3. So this is a solution, okay? So if I pick up a 0 by itself, this is a solution. Now let's go to 1. Is 1 a solution? Well, what's the distance of 1 from 0? It's 1, right, which is less than 3. So 1 is also a solution. Let's go to 2. Is 2 a solution? What's the distance of 2 from 0? Well, it's 2 units, right? So this is still a solution. How about negative 1? What's the distance of negative 1 from 0? Well, the distance of negative 1 from 0 is 1, so it's less than 3, right? So I'm looking at all those numbers whose distance from 0 is less than 3. How about negative 2? Is this a solution? Yes, because all numbers, well, because negative 2 is 2 units away from 0, so the distance is 2. How about something like negative 1.5? Is this distance less than 3? Yes, it's 1.5 units from 0, so it's less than 3. How about 0.5? Is this a solution? Yes, because it's 0.5 units away from 0. How about 0.5? That's a solution, right? How about 1.5? Yes, so any number here from negative 2 to 2 will work for sure. How about negative 2.5? How many units away from 0 is this? That's 2.5, so it's also a solution. How about 2.5? That's also a solution. How about something like 4? Well, if my point is here, then it's going to be 4 units away from 0, so it's more than 3. So this is not a solution. Finally, what can we say about negative 3 and positive 3? Notice here I'm putting some roundouts, so some open circles, because these points are exactly 3 units away from 0. But here I'm looking for absolute value of x which is less than 3, not equal to 3. And therefore negative 3 and 3 are not solution. But anything in between it is. So all of these points from, so I'm going to mark this a little bit from negative 3 to 3, are solutions of the absolute value inequalities, okay? So except -3 and +3, okay? So let me graph this a little bit better. So we have -3, we put an open dot, +3, we put an open dot, and then we shade anything between -3 and 3. So this is the solution set. Now, how are we going to write this algebraically? So that's what we just did. We just did is a graphing representation of our solution. Algebraically, we are going to say that x needs to be less than -3. Excuse me. X needs to be less than 3, sorry, so less than 3. But at the same time, x must be greater than -3. So, and x must be greater than -3. So, the reason we put and is because each statement by itself is not going to work. In fact, if I only say x is less than 3, this is not a true statement. Because -5 is also less than 3, but it's not a solution of our inequality. If I say by itself x greater than -3, that's not true. Because if I am a 4, well, 4 is greater than -3, but it's not a solution. So the reason we put and is to specify that anything between -3 and 3 will work. A different way to write this is also, probably is more intuitive, is to write x between -3 and 3 this way. It's the same thing. What you just see here is just a different way to rewrite x less than 3 and x greater than -3. So, but this probably, is a more intuitive understanding because I'm saying you can see here visually that x is between -3 and 3. Okay, so you can use this notation if you want. Okay, so here in example 2, the only difference with example 1 is that there is an equal sign. So I want to look for all the values of x that in absolute value are less than or equal to 4. So this means I want the distance to be, must be less than or equal to 4. So we can also have an equal to 4. Which means anything between -4 and 4 will work, but -4 and 4 will be included in this case in our solution, because if x is equal -4 or x is equal 4, then the absolute value will be 4, which is less than or equal to 4. Of course, it's not less to, but it's equal to. So the equation will be satisfied. So anything between -4 and 4 will work, -4 and 4 included. So, if you want to write your answer, you can either say x less than 4 and x greater than -4, or more simply, you can just write x and say greater than -4, less than, oh, I'm sorry, there must be an equal sign here, so less than or equal to 4, okay? Alright, so here there is another practice problem. You should try this by yourself first. So what we have is that the absolute value of x is less than 1. Well, based on what we just did so far, we're going to put an open dot at -1, an open dot at 1, and we're going to shade anything in between. That's how you represent graphically your solution. Algebraically, you're going to write x greater than -1 and x less than 1. And in this problem, less than or equal to 3.5, it means there's going to be a closed dot and -3.5, a closed dot and 3.5, okay? And then you're going to shade anything between these 2 points, and your solution will be x greater than or equal to -3.5, okay? And then less than or equal to 3.5. Okay, so at this point, let's see how to, so I'm going to show you this example, and then I'm going to ask you to work the second page. So here I have absolute value 4x plus 5 is less than 7. So what we're saying is that the number 4x plus 5, we don't know what's x, but we know that based on x we get a number out of this. So the number is, so the absolute value, remember, represent the distance of a number from 0, and we know that the distance of the number 4x plus 5 from 0 is less than 7, okay? So let me actually write this a little bit better. So make more sense to write that the distance of the number four x plus 5, whatever it is, from 0 is less than 7. So what does this mean? This number, 4x plus 5, if I want this distance to be less than 7, then this number must be between negative 7 and 7, right? So it needs to be someplace in this area, right? Between negative 7 and 7. And therefore, we are going to set up two inequalities, right? So if this number is between negative 7 and 7, it means that this number must be, so 4x plus 5 must be less than 7, and 4x plus 5 needs to be greater than negative 7. And if this still is confusing to you, let's come back to what we wrote here when we said absolute value of x less than 3. I say x must be less than 3 and x greater than negative 3. So the two inequality comes from this statement, right? In this case, instead of having x, we have 4x plus 5. That's the only difference. Alright, so at this point, you're going to solve these two inequalities like you solve any other inequalities in algebra 1. So what you're going to do, you're going to get x by itself. Just remember that anytime you divide by negative sign, you need to flip the inequality symbol. Okay? So we're going to subtract 5 from both sides. This simplifies. So now we are left with 4x less than 7 minus 5, which is 2. We divide both sides by 4. We are dividing by positive numbers, so I don't need to flip the inequality sign, and we end up with x less than 1/2. Okay? And from here, we subtract 5, and we end up with 4x greater than negative 7 minus 5 is negative 12. We divide by 4, so we end up with x greater than negative 12 over 4, which is equal to negative 3. Okay? So, what we just said is that x needs to be less than 1/2 and greater than negative 3. How are we going to represent this? Well, 1/2 is going to be here, between 0 and 1. I'm going to put an open dot, not close. Open because I don't have an equal sign. There is only a less sign. If there was an equal sign, I would put a closed dot. And then greater than negative 3, so we go at negative 3, we also put an open dot because there is no equal sign. And anything in between will be shaded because any value of x in between negative 3 and 1/2 will work. In fact, we can check it, at least one of these numbers will work. If I plug in 0, 0 should satisfy my original equation. In fact, if I plug in 0, 4 times 0 is 0, 0 plus 5 is 5, so we are left with the absolute value of 5, which is 5, and 5 we know is less than 7, so that will work. And you can verify that any other number between negative 3 and 1/2, with the exception of negative 3 and 1/2, will work once plugged in into the original inequalities. Okay, so what I want you to do next is try to work these problems by yourself in this page, and then I'm going to create a video with the solution of those problems so you can check your understanding.